Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. So we're going to be talking about how do we find the perimeter of a sector, all right? So please, it's very important that you review the previous videos, especially when we talk about circles. Make sure you understand everything. I've talked about different concepts, the segment and the rest of it, and sector, and how do you find the area of a sector. Here, I'm going to ask you how to find the perimeter of a sector. All right, so before I proceed, don't forget to like, share, and subscribe. If you've not clicked the notification bell, I don't know what you're waiting for. Please do so that when I post new videos, you'll be the first person to know. All right, so when we talk about the perimeter of a sector, what we're actually saying is that the perimeter of a sector is just like the distance around the sector. So remember in the previous video, I told you that the sector looks like this, right? So these are the radius, okay? And this is the length of arc. So the distance around the sector is what we call the perimeter of a sector. So from this now, you can see to get the perimeter, we have to add the two radii and the arc length of that sector, all right? So let's get cracking. Because I know students will take notes, I'm going to write down what I just said. So the perimeter of a sector is the distance around the sector. Okay, so so that means what we do, we find the perimeter by adding together the lengths of the two radii and the arc length. Okay, so we find the perimeter by adding together the lengths of the two radii and the arc length of the sector. Okay, so to get the perimeter, what you need to do, you need to add the two radii as well as the arc length of the sector. All right, so let us put this into formulas now. So we've already agreed that is adding the arc length and that of the sector. So therefore, we can now say that the perimeter of a sector okay, the perimeter of a sector is equal to the what? The arc length plus the radius, the two radius. So the radius, which is the R, and the other radius, which is also the R. So that means technically we can say it's equal to the arc length, okay, plus 2 radius, all right? Now, in the previous video, I've talked about how to find the arc length of a sector, all right? So please make sure you go back and review how to find the arc length. But what I'm going to do here is that I'm going to do a quick reminder of how to find the arc length. Okay, I'll do a quick reminder. So in degrees, so when we're talking about degrees, the arc length is equal to theta over 360 times 2 pi r. Okay, so if this is in degrees, so if the theta is in degrees, okay, or you can say theta over 360 times pi d. So remember, I told you then that in this case, theta in degrees, okay? So the theta here is in degrees. If it was in radian, you have to use pi r. Is that making sense? So if it was in radian, it's going to be pi r. So you have to be very, very careful. So in this case here, it's in degrees. So you have to know that as well. So we can then push this now and put it in the formula. So the arc length, so the perimeter, I beg your pardon. So the perimeter of a sector will be equal to the arc length, which is theta over 360 times 2 pi r plus 2r. Okay, so if theta is in degrees, or you can say is theta over 360 times pi d, if you're given a diameter, plus 2r. Okay, now, but if it was in radians, so if, for instance, it was radians, so you know that if theta is in radians, it's going to be theta r, okay? So, for instance, so what I'm saying is if theta was in radians, okay? So if theta was given in radians, I've talked about this before, then the arc length will be equal to theta r, okay, if it was in radians. So you have to be very careful. You have to be sure you understand the unit. So then the perimeter of the sector will be equal to theta r, okay, plus 2r. So if it was in radians, so you have to be careful. So basically, I've talked about all this before, so we know what each of these represents. So we know that when I talk about r, where theta is the angle, okay, the angle. So here, I can say the angle of sector, all right? Now, it can be either in degrees or radians, okay? Now, we also know that r, when I talk about r, I'm referring it to the radius, okay? The radius of the circle. Now, when I say d in this formula, I'm referring to the what? The diameter. Then we know the pi. Pi is, you know the value, 3.142. Then that is it. So that's how you get the perimeter. So the perimeter of a circle, of a sector, is theta over 360 times 2 pi r plus 2r, or it can be theta r plus 2r, depending if you're working in radius or what? Sorry, in radian or degrees, okay? All right, so let's write down the 5 steps to solve this. So how do you solve questions like this? So the 5 steps. So the 5 steps here. Number 1, the first thing you have to do is that you have to find the length of the radius or diameter. Okay. All right. So number 2, after you found the length of the radius or diameter, the next thing you have to do is to find the value of theta. So basically, which is the angle of the arc creating the sector. So remember, we talked about the minor arc and the major arc, or the minor sector and the major sector in the previous video. So basically, the theta is the angle of that sector, okay? So then next thing you have to do is to find the value of theta. So theta can either be in degrees, okay, or it can be in radians. So you have to be careful, all right? And I told you the difference between both of them. So the theta, which is the angle of the arc creating the sector. Okay. So you have to be careful. You need to know if it's the minor, okay, the minor sector. So you have to ask yourself, is this the minor sector or is it the major sector? Okay. So usually in the major sector, you have to subtract most times from 360. So you need to be very, very careful which part you're being asked to do. So number 3, then you now find the arc length of the sector, okay? The next thing you have to do is to find the arc length. Okay, using the formula. Okay, so we know, I told you, so if theta was in degrees, okay, the arc length will be equal to theta over 360 times 2 pi r. So if theta in degrees, okay? So if the theta was given to you in degrees, or you're working with theta in degrees, you use this to get the arc length. Or you can say it's a theta over 360 times pi d, all right? So sometimes they give you the diameter, or sometimes they don't. But if theta was in radians, the arc length will be equal to theta r. So in this case here, the theta is what? In radians. So you need to be careful. So you need to look at it carefully and see whether you were given in radians or you were given in what? Degrees. Now, when you're done with that, the next step is then you can now find the perimeter of the circle. So then you now find the perimeter of the sector. So you find the perimeter of the sector using the formula. So the perimeter of a sector is going to be equal to the arc length. So the arc length that you calculated plus 2r, okay? Then number 5, what you then do then, you then what? Simplify, okay? And that's what you do. So let's pick some examples now, all right? Let's pick some examples. So let's say we have this example here. Number 1, we're told, find the perimeter of the shape below. So we have something like this, like that, and like this, okay? So we're told that this was 10 centimeter, and this was 100 and what? 20 degrees, okay? All right, so remember the first step, step 1, I told you we need to know what the radius was. So here, the radius, the R, is equal to what? 10 centimeter. Now, step 2, we need to know what was theta. The theta in this case was what? 120 what? Degrees. So this is the angle that subtends the what? The sector. All right, so let's go to step 3 now. Step 3, we're going to find the arc length. So step 3, so because it was in degrees, the arc length now, the arc length is going to be equal to theta over 360 times 2 pi r. So that will give me the theta is 120 divided by 360 times 2 pi 10. Is that making sense? So when you now do that, the answer is going to be, take this up a bit. So the arc length now when you put this in your calculator, is going to give you 20 over 3 pi. Now, when we've gotten the arc length, step 4 and 5 together, we'll then put it in the formula and simplify. So step 5, so step 4 and 5. So I'll combine both of them together. So the perimeter of a sector is going to be equal to the arc length, okay, plus 2r. So the arc length we have here was 20 over 3 pi plus 2 into bracket 10. And when you solve this, it's going to give you 40.94. And that will be the answer for this. All right. So you see you found the arc length. So you have to be careful if you have it in degrees or you have it in radians. All right, let me take one more and I will call it a day for perimeter of a sector. All right, so let's solve this question. Number 2, we're told to find the perimeter of the shape here. So something like this. Then we had something like this. And we're told that this was what? Pi over 4. And the length here was 8 centimeter. Okay. Now you can see in this question here, we're not told to find the minor, we're finding the major. Okay. So you can see that this pi over 4 was responsible. So if I'm to draw this again, so you notice that the pi over 4 that we had here, the pi over 4 was responsible for the what? The minor sector here. But that's not what the question wants you to find. It wants you to find the major sector. So therefore, it has to be the angle here. Is that making sense? So the angle there. And we know the sum of angle in a circle is 360. All right. So let's go. Let's start working. But before we proceed, it's also because the angle was in radian, you can either work with radian or you can work with what? Degrees. So if you want to work with degrees, you have to convert the radian, the pi over 4, into the equivalent degrees. Or if you just want to work with the radian directly, then you have to use the arc length formula with radian. So I'm going to do both of them. So just in case, because I know some students are more comfortable with degrees, so they have to convert to degrees. Some are comfortable with radian, so I'm going to work with both of them. All right. So what I'm going to do, I'm going to divide the screen into 2, okay? So I'm going to divide it this way. So we're going to do the same thing. So if I'm working with, I'll put this for degrees. If you want to work with degrees, and if you want to work with what? Radian. So you will see at the end of the day, we're going to get the same thing. All right, for degrees, step 1. All right, what do you have to do? The R is equal to what? 8 centimeter, which is the radius. So even though you're working with radian, the radius is also going to be what? 8 centimeter. Nothing changes, right? Good. Now let's go to the next one. Now step 2, all right? The theta here. Now, in this case, because in radian, the theta is going to be pi over 4 radian, right? Because we're given in radian. But because I want to work in degrees, I have to convert to degrees. Does that make sense? So here, if I'm working in degrees, I have to convert that theta to degrees. So it's going to be, so remember, we're going to convert the radian to degrees. Okay, so take this up a bit. So I told you that when I have a video on converting radian to degrees and degrees to radian, so please go back and have a look. So I told you that 360 degrees is equal to what? 2 pi radian. So, but we are converting pi over 4. So pi over 4 is going to give us what? Pi over 4 radian. What will it give you? X, okay? Then you cross multiply. So therefore, X is going to be 360 multiplied by what? Pi over 4 divided by what? 2 pi. Okay? And when you press your calculator, it's going to give you 45 what? Degrees. So that means if I'm working with degrees, what I'm going to use as my theta is going to be 45 degrees. But if I'm working with radian, I'm just going to use pi over 4 radian straight up. Okay? Good. So the first thing you have to know if you're working with degrees or radian, and then you have to convert accordingly, okay? Now, but if you look at the question, we are not looking for the minor sector, we're looking for the major sector. So we're looking for this part here. Does that make sense? That's the part we're looking for. We're looking for the angle, this part. So what we have to do, we know that the sum of angle in a circle is what? 360 degrees or 2 pi. Does that make sense? So we have it here, the sum of angle in a circle. So let's take this out. Bring this bit down. Yep. So, but we're looking for the angle in the major sector. So the angle responsible for the major sector okay? So the major sector will be, so because we're looking for the major sector there, what you're going to do is that because we know the sum of angle in a circle now, because we're working with degrees, the sum of angle in a circle is 360 degrees. But if you are working with radian, the sum of angle is 2 pi. So you have to know the difference. But if it's with radian, the sum of angle in a circle is 2 pi. Are you seeing it? The sum of this is 360, while the sum of angle in a circle is. So if we go back to the top here, all right? So that means in order to get, since we know the sum of angle is 360, so in order to get this angle now that is being subtended here, the angle here is going to be in degrees, is going to be 360 minus, we said it was 45 degrees, right? 45 degrees. But to get the angle here, if it's in radian, it's going to be 2 pi minus pi over 4. So depending if you're working with degrees or radian, we determine how you go about it, okay? So now let's go back. So that means in order to solve this, we have to do the first one. So in this case, it's going to become 360 minus 45 degrees. So that will give us the angle that we're going to use. So and that will be 300 and what? 15 what? Degrees. So this is the theta we're going to use to solve. While for this, we're going to say it's going to become 2 pi minus pi over 4, which is going to give us 7 over 4 what? Pi. So this is what we're going to use to solve. Are you seeing it? So this is going to give us 7 over 4, while this is 315. So we're still working as well. Then the next thing is that we're going to find the arc length. So that's step 3. Step 3, we're going to find the arc length. So because we're working with degrees, okay, the arc length is going to be equal to theta over 360 times 2 pi r. Are you seeing it? But if you're working with radian, the arc length is going to be theta r. Okay? So let's put it here. So when we do this, so let's change this a bit. So take this up a bit now. Okay. So we'll continue with that. So the arc length now is going to be equal to the theta, which we solved then. We got it to be 315, okay? So the arc length was 315. So we have 315 divided by 360 times 2 times pi. And what was the radius in this question? We had the radius, I believe, to be 8, just to confirm again. Yep, the radius was 8 centimeter. So we'll go back now. The radius was 8 centimeter, was 8. And this is going, when you press this in your calculator, it's going to give you what? 14 pi. Now, when you do this as well, the arc length, now the theta, we had it to be 7 over 4 pi. Times the radius, which is 8. And this is going to still give you what? 14 what? Pi. So you can see, regardless if we're using the radians or degrees method, we still got what? We still got the same thing for the arc length. So the arc length here is exactly the same thing as the arc length here. But you just have to use the right method to solve it. Is that okay? Now we found the arc length now. So what's the next thing to do? We need to go to step 4 and 5. So step 4, we need to find the perimeter. Okay? So the perimeter of a sector will be equal to the arc length plus 2r. Okay, so the arc length, we got the arc length to be, I think 14 pi, yes. So we got the arc length to be 14 pi. So it's going to be 14 pi plus 2. We know the radius is what? 8 centimeter. And when you do that, when you press this in your calculator, the answer you will get will be 59.98 centimeter. So the answer for this is 59.98 centimeter. All right, so that will be that for that, okay? And that is how you find the perimeter of a sector. So I'm going to see you in the next video. So don't forget to subscribe so that when I post new videos, you'll be the first person to know. And if you have any question, please do not hesitate to send me an email and I'll get back to you as soon as I can. All right, see you soon. I'll see you in the next video.